In these exercises, we're being asked to find the midline of sinusoidal function equations. Here we can see we've got g of x equal to a sine function that's being transformed with these various elements. Before we start discussing the very simple algorithm for finding the answer to these particular types of questions, we'll take a look at this particular function and how it gets transformed and what we receive. You should be able to begin to get an idea based on the transformations that we've discussed, what each of these values is doing to the function. And the best way to think about it is to first imagine the standard sine wave and then add in these transformations one at a time. So here we have a -1 being multiplied by the trig function, and what's that is going to do is sort of flip all of our positive values to negative and all the negative values to positive. So instead of starting out going up, that negative value is going to start us out going down. Then we go inside the parentheses and we're going to modify the input to the function before it goes into the sign. So we're going to take whatever the input is and multiply it by 8. And we discussed how that is related to the frequency of the function. And we can see that instead of seeing one cycle within 2 pi radians, we're going to get 8 of the complete cycles within that 2 pi as our frequency of the equation. Then we're going to do a horizontal shift, which in sinusoidal functions is often called a phase shift. But we're going to move this to the right with this negative value by 3. And finally, we are going to do a vertical translation or shift this thing up by 5. So what we have here is this original sine function transformed to become the one in the problem. What we're being asked to find, though, is the midline. In other words, the line that divides this oscillating behavior right down the middle. And actually, the very simple and basic way to do this is simply look at the vertical translation, because that's where the midline goes. And I can see it is just equal to the value of the horizontal shift. So the correct answer here is, in fact, 5, because that is the horizontal shift. And now if you were having difficulty with this, you probably see how obscenely easy it is. And the second question, again, we can simply ignore all of these other transformations, because what affects the midline is this vertical shift that comes after the trig function, plus 8, -10, and -6. Those are all the midlines are simply shifted by this value. But for the sake of thoroughness, let's take a look at it. Here's each one of these functions. They're being transformed in different ways. This -9 is flipping the trig function over and increasing the amplitude. We can see that it now goes up 9, down 9, so it's all spread out. Pi over 2 is the shift in frequency, so we see that it's occurring a little bit more quickly. And -6 means we've shifted to the right. That's the horizontal or phase shift. And finally, for the center line, y equals 8, we've shifted this thing up from 0 to 8. That's where the midline of that function is. Similarly, for this one, we get a -5, so we've increased the amplitude, and we can see that it then stretches from between -5 and -15. We've increased the frequency by 2 pi. We've shifted horizontally, and we've moved the entire thing down, the midline down to -10. And the last one in this set, -3, so the amplitude is more than 1. Frequency by pi. We've shifted it left by 2, and then the -6, the midline, shifted down to -6. So those are the only 4 transformations we really need to be concerned with: the amplitude, the frequency, the horizontal or phase shift, and the vertical shift. And the midline is always related to that vertical shift. So that makes the algorithm for finding the answers to these really straightforward.